All right, here we go again. I am going to record myself doing all of the balancing equation questions. Hopefully this will be useful. I think just quickly before we start, I'm just going to talk about the steps because I am going to try to use the steps as much as possible as well to demonstrate the thinking process. So you always want to start by using oxidation numbers to identify the oxidizing and reducing agents. You also want to quickly consider whether there's anything in the equations that you can split in terms of what species that you should use. We'll discuss this when we get to the specific examples. And lastly, with balancing half equations, you can use cohes if you have an acidic condition, if you have a basic condition, or when the condition is neither acidic nor basic. There are a few other things that you do have to do. All right, so let's just start with the first question. So we have question 1. You need to balance the following half equations given the conjugate redox pairs. So you are essentially given the reactant and the product, and this is not going to give you a full equation. This is just going to be a half equation. In each case, assume that the reaction takes place under acidic conditions, which means that we are allowed to use cohes. We will talk about other conditions later. Acidic conditions just mean it has some form of hydrogen ions or acid in it. All right, so I am going to start by I'm going to start by finding the oxidation numbers. That was weird. All right. So oxidation numbers, oxygen is going to be 2, negative 2. So negative 2 for oxygen, which means that all the oxygen is going to be -6, and since you want the total oxidation numbers to be -2, this has to be +4. So the oxidation number for each sulfur atom is going to be +2. And then moving on to this side, each oxygen is -2, which means that the total is -8. So the sulfur has to be +6 in order to get a total charge of 2-, and since there's only one sulfur atom, the oxidation number of sulfur is +6. So there is an increase in oxidation number for sulfur. There is no change in the oxidation number of oxygen, which means that you can assume that sulfur is your key element. And the other thing to keep in mind as well is that because there is an increase in oxidation number, so increase in oxidation number, this means that this is oxidation and there must be a loss of electrons. Loss of electrons. Okay, I think that's everything. If you look at these species, they are already ions, so you can't split them at all. Ions, so cannot be split. You cannot split an ion into smaller ions, which means that I will need to use cohes in order to balance this. I don't think you can split anything for question 1 anyway. All right, I'm just going to rewrite the reactant and the product. So I have S2O3 going to SO4, 2-, and if we are familiar with cohes, KOHES. So K, you're going to start by balancing the key element. The key element in this case is sulfur. There are 2 sulfur atoms on the reactant side, so I need to put a 2 here so that the key element's balanced. The second step is to balance oxygen by adding H2O. So it's very important that you actually add H2O and not using other means to balance oxygen. So there are 8 oxygen atoms on the right side right now, and I only have 3 on the left, so I need to add 5 H2O. So now oxygen is balanced. I need to balance hydrogen next by adding H+ ions. There are 10 hydrogen atoms on the left side, so I need to add 10 H+ on the right side. This is why you need to make sure that the condition is acidic, because hydrogen ions would only exist in an acidic condition. So if the condition is not acidic, then we're going to have to do further manipulation in order to reflect what the condition is. But anyway, in this case, it's just H plus. The next step is always interesting. You need to balance the charge by adding electrons. And keep in mind that each electron is 1 minus. So if you look at the left side right now, you have a total charge of 0. Everything is neutral. No, actually, everything is not neutral. I just made that mistake. The total charge should be 2 minus from the S2O3. If you look at the right-hand side, the total charge is supposed to be 6 positive. It's not 4 positive. You need to take the coefficient in front of the species into account. If you have 2 SO4 2 minus, it will contribute to a total charge of 4 minus, and 10 H plus will be 10 plus. So the overall charge is 6 plus. So in order to balance the charge, because I'm adding electrons are negatively charged, I will have to bring 6 plus down to 2 minus. So what I'm going to do is I'm going to add 8 electrons to the product side. And notice how this fits with our prediction earlier that this is oxidation and should have a loss of electrons. Last thing I'm going to do is to put in states. So AQ liquid, AQ, and AQ. You don't need a state on electrons. Now, before we finish, I just want to point out that you can do one quick thing to check whether your equation is correct. Besides the fact that if it is oxidation, then you should have electrons on the product side, is that sulfur has an increase in oxidation number from positive 2 to positive 6. And that means that it must lose 4 electrons. So, yes. So it loses each sulfur atom must lose 4 electrons in order to increase its oxidation number from positive 2 to positive 6. And because you have 2 sulfur atoms, it must lose 8 electrons. So the number of electrons that is lost based on the oxidation numbers should match the number of electrons required to balance the charge, which is a strong indication that your half equation is correct. So that's that for part A.